Hello, everyone, and welcome back to Identity Insights by Indicio. Today, we'll be taking a look at a recent meetup that Indicio hosted on DIDComm V2 and its implications on the future of the internet. The two speakers today are Sam Curren, Deputy CTO of Indicio, and Daniel Hardman, CTO of Provenant. And they kind of go over basically what DIDComm is and how they foresee it really impacting the future of the internet. Without further ado, let's jump right in.
I'm going to focus really on what DIDComm's true value proposition is a little bit. And then I think Sam's going to talk about the implications of that value proposition in the larger internet as we move forward. I'm going to use some slide material that I have talked to before, but I'm going to speak to it a little bit differently. So hopefully nobody will feel bored here. This is a screenshot from the DIDComm spec, DIDComm V2 spec. And what I want you to notice from is the
it's not actually on a call. No.
The parts that are colored there, the red box and the yellow box. What is DIDComm is the red box, and then this yellow thing is what I want to kind of talk about, that it's the second half of the sentence, the part that's in red, not the first half of the sentence. That's interesting. If you look at the first half of the sentence that I have not highlighted, it talks about secure and private communication. A lot of folks that encounter DIDComm think that secure private communication is its value proposition. And it's true that DIDComm cares about that, but that's table stakes, not its main value proposition. Hopefully I'll convince you of that as I go on here. So let's have a look at a matrix that I built. Those of you who saw me talk about DIDComm misconceptions at IIW saw a matrix a little bit like this, but this has been changed a bit since you may have seen it before. This is comparing different technologies and it's talking about, different features that they might have. The thing I want you to notice here, first of all, this is part of a very large matrix. There's a lot of ways to compare things. But if you look at the columns, you've got DIDComm as a column, you've got web services and TLS as a column, you've got email. These things are not all, they're apples and oranges. They can't be directly compared. The architecture section of this slide deck has, 15 lines or something there, where I've mostly compared things directly straight across. But in fact, we all know that email and web services are really fundamentally different in important ways, and they have different use cases. So when we talk about what DIDComm is used for, we sometimes tend to do head-to-head comparisons that hide deeper issues. And I think Sam's going to show why web services and that whole world of open API Swagger stuff that we all know and love, that has become so fundamental to Web 2 and is turning into something important for Web 3 as well. That world is not really a very good analog in some ways to what DIDComm offers, and the two can be used together. So I'm not going to dive into this matrix in great detail, but keep in mind that there's some very interesting information that could be used, and the important thing to know is, what are you comparing? Are they apples or oranges? This is the definition I've used in other places for DIDComm. What I'm going to do is very quickly talk about each of the colored boxes on top of that definition. So if DIDComm is a framework, what do we mean by framework? We don't mean an API, we don't mean an algorithm or a data model or a format, and we don't mean a library or a component. What we mean rather is a structure that is used to enclose or support something else. And the something else is part of why DIDComm exists that makes it unique. It's higher level protocols, which we'll talk about. Safety in this definition is more than just security. It's also more than security plus privacy. Some of the features that we like to talk about in the decentralized identity community, I categorize as safety features, even though they're not often seen that way by a cybersecurity party. So for example, having a form of communication that is resilient, that is censorship resistant, that is owned by no one. These are all, in my opinion, safety features. And safe is an important word for DIDComm. Now this next phrase, structured interactions, is also important. There's lots of ways you can interact. If you talk to your friend over, let's say, a phone call, there's no formal structure to that phone call. You might have a convention that you say hi when you pick up and bye when you hang up. But other than that, you can say whatever you want. You can have long periods of silence. You can turn your camera on. You can play cat videos. You can do whatever you want. There's no structure to the phone call. And that same kind of characteristic is true of many other ways that we interact. On Slack, there's a little bit of structure, but it's not a structure that you could map onto, for example, the process of applying for a loan or the process of giving formal feedback or testimony in court or all these other things. Those are highly structured interactions, and DIDComm cares about structured interactions. It doesn't only support the unstructured variety. And lastly, built atop DIDs. We all know why DIDs are important and interesting, but there are some possible analogs to DIDComm in worlds that aren't DID oriented, and that is interesting. So what does DIDComm tell you how to do? This is a long list. I'm not going to read it all, but suffice it to say that DIDComm answers a whole bunch of questions in a standard way. And these are all questions that turn out to be important if you care about trust and you care about decentralization and you care about composition of higher level protocols. There are a bunch of questions that DIDComm doesn't answer, and sometimes in the community, people have thought that DIDComm was tackling one or more of these questions and been surprised when we said, no, that's actually not a DIDComm concern. So here are some examples of higher level protocols that you could build with DIDComm primitives. Hopefully some of these protocols look quite interesting to you. Others might be something that you think nobody wants, or you might say you'd never thought of that before. The big thing I want you to get out of this list is it's a lot longer than the first two. We tend to talk about issuing credentials and proving things with credentials as like the whole use case of SSI. And in fact, there's lots and lots of use cases. You want to run a MOOC with 10,000 students across the internet and test them, you might need some trust protocol.
So if you think about about DIDComm sharing some of the attributes of email and some of the attributes of APIs, we end up with a really nice combination of the two. So among other things, we get semantic interaction, something that we never got to with email. And so the messages have schemas. There are specific purpose. There's expectations about what you do or what the information means when it's transferred between parties. Authentication and encryption are standard. That's just kind of included. You don't really have to think about that. The spec already includes that, and you don't have to. You have to invent something yourself, which is very nice. But you also end up with, and this is the really important bit, peers with identical capabilities. Any person who can send or receive a DIDComm message has the same capabilities within DIDComm as any other party that can send or receive a message. There is also, you'll notice the return of these gray boxes here in the middle. There are also some uninvolved infrastructure in the middle that helps this. And you're going to find this anytime you have a message-oriented architecture that does not require high availability of a message destination. And that's important, because DIDComm actually excels at interacting with people-oriented devices. And what I mean by that is things like phones or tablets or computers that are typically not on all the time, nor connected to the same internet, or certainly not highly available in the server sense of the word that would be required to host something like an API. And that balance, the fact that everyone is a peer here, is really powerful. So DIDComm combines the best, I believe, of email with the best of APIs in a really powerful way. Do I think that DIDComm is going to immediately kill either one of them? No, probably not. And I'll get to a Venn diagram in a second. The main point that I'm hoping to convince you of here is that DIDComm picks up where email and APIs leave off. They have limitations and they have things they don't do well. And DIDComm picks right up in those areas and can support a manner of interaction that is very powerful. And semantic peer-to-peer interaction, Daniel had that really cool slide of potential protocols, for example. Those are all semantic peer interactions that could occur in a really trivial way. One of the things that an example of a semantic peer interaction that I would really like is that I'd like to be able to ask a business that I frequent when their hours are today, not generally on a Tuesday, but today, this Tuesday, because this Tuesday might happen to be Christmas Eve, or it might happen to be another holiday, or there may have happened to be a power outage all day yesterday, and they're not capable of being open today. And it's different asking what your hours are on a Tuesday and what your hours are today. And that's the type of interaction that I think would be really useful, and that I could engage software to help me manage my life in a really useful way.
All right. Thank you all so much for watching. If you found this topic interesting, I highly encourage you to check out the full Meetup recording, which we'll have linked in the description down below. If you'd like to learn a bit more about decentralized identity in general, be sure to subscribe to the channel, and we'll continue to bring you some educational content. Thanks so much. Bye.